Hello everyone and welcome to another class of Physics 9702, and today we're going to discuss about speed and velocity. We will be discussing about what is speed, what is velocity, why speed is a scalar quantity but velocity is a vector quantity, right? So first I'll be explaining speed and then we'll go on to study about velocity. Let's say we have a 2-point, one is called A and one is called B, right? And a motorbike travels from A to B, right? And let's say it travels about 10 kilometers, right? Maybe we can say 120 minutes. So we have time taken to travel from A to B, and we have traveled the distance is about 10 kilometers, right? So from these calculations, from these numbers, we can tell about the speed of the motorbike from A to B. Remember, it won't tell about the speed of the motorbike at any instant between A to B. It'll tell about the average speed of that motorbike, right? So we have distance that is represented by D. We have time that is represented by small t, and we have V that is speed. So we can represent mathematically V is equals to D over T, right? What is D? D is for distance and T is for time. So this is called the average speed of that motorbike, right? It would not tell about the speed of that motorbike at any instant between from point A to B, right? And also it won't tell you about it whether it's increasing speed or decreasing speed. So it'll only tell about the average speed from A to B, right? And we have speedometers in our vehicles, like in cars. We have speedometers that tells about the instant speed of the car traveling from one point to the other point, right? And now let's discuss about the SI unit of the speed. We all know that distance is measured in meters, right? And time is measured in seconds, right? So V is equal to meter over seconds, right? So what would it come out? V is equal to meter per second, right? So SI unit of speed is meter per second, though we have other units to measure speed on depending on the occasions, depending on the circumstances. We can measure speed in kilometers. We can measure kilometers per minute, miles per hour, so we have all other units of the speed depending on the situation and depending on the circumstances that we have, right? So this was SI unit of speed, that is meter per second. Got it? You get the idea? And now we discuss how speed is a scalar quantity, which is very important. How speed is a scalar quantity. It's a question. Let's get back to the formula of the speed. V is equal to D over T. Remember, D is for distance And we all know distance is a scalar quantity because distance hasn't have any specific direction. You are moving from point A to point B. You can go this way, like this way, and then you can reach point B. You are changing your direction. So this travel is not unidirectional. Okay, so that's why we say distance is not a unidirectional travel. So distance is a scalar quantity. And of course, time hasn't have any direction. That's why time is also a scalar quantity. So both quantities which are responsible for speed are scalar. So that's why we say that speed is also a scalar quantity. So we can write as distance and time both are scalar quantities which are responsible for speed. That's how speed is also a scalar quantity, right? And the next we have velocity. Now, velocity in the first portion, in the first case we discussed, if you want to travel from one point to the other point, like this point is A and this point is B, and you travel, you cover a distance like this by changing direction. This is called a distance, right? But what if you go very straight to B and you do not change your direction and you move in a unidirectional distance, right? And it's also a shortest distance between 2 points. So the shortest length between 2 points is called displacement, right? If you move unidirectional from point A to B, you cover displacement, right? So we define as velocity is also denoted by V. Velocity is defined as d over t. Now this d is called a displacement. You can denote it with different letter, but d is okay for displacement. In your questions they'll be mentioned what are you finding out, whether it's a speed or whether it's velocity. You have to define, you have to decide if it includes displacement, which is unidirectional. Definitely you're going to find out velocity. If it includes distance, which is of course not unidirectional, so you're going to define, you're going to find out speed, right? So we have v is equal to d over t, and this v is also definitely an average velocity from point A to B. It does not tell any instantaneous velocity at any point of that motorbike, car, whatever you have, right? So this was an average velocity, and now let's talk about the SI unit. Of course, distance or displacement is also measured in meters, and time is of course measured in second, so it becomes meter per second. So SI units of velocity is meter per second. Of course, we have other units, alternatives, depending on the situation, depending on the circumstances. Like if you're having long um, displacements, definitely you'll find out in kilometers per hour. Maybe you can say meters in minutes and millimeters in seconds. Like we talk about the speed of light that travels meter per second, right? So velocity is calculated in meters per second in SI units. Though we have other alternatives, but in your course or syllabus, we mostly find out velocity in meter per seconds, but it can be measured in alternative units depending on the situations and depending on the circumstances, as I already mentioned, right? If examiner asks you to find out velocity in meter per second, so you have to find in meters per second. Otherwise, it's fine to find in any other alternative units, right? So this was velocity, and now let's discuss why velocity is a vector quantity. Why velocity is a vector quantity. Let's go again to the formula. V is equal to d over t. D is displacement, which is unidirectional, and of course unidirectional quantity is a vector quantity, and time is a scalar quantity. So what do we have? We have the main quantity, that is displacement, which is a vector quantity, and this velocity is definitely depending on this vector quantity. So we say that velocity is also a vector quantity because velocity is a vector quantity because displacement because of displacement, and we all know displacement is a unidirectional and it is a vector quantity. Because it's a vector quantity, that's why velocity is also a vector quantity. Hope so this clears your mind. And next on we'll move on to distance, displacement, and of course then acceleration, and then we'll be studying about how we use graphical method to represent distance, displacement, speed, and acceleration, right? So next on I'm going to discuss about distance, right? You might have a very brief idea about this distance. What is distance? So we have 2 points again, that is A, and we have a point B, and you want to go to point B from A. Definitely the path or the length you cover to go from point A to point B, this is called distance. And it is a scalar quantity because you do not go in a unidirection path, right? You can change your direction. For example, you are moving from one city to another city, that is city number 1 and that is city number 2, and you are traveling in your car. Definitely you're not gonna get there in a unidirectional path. You can change your direction, right? So what are you covering? You are covering a distance, right? So the longest length you can say between 2 points is called a distance, right? On the other hand, and it is measured in meters, kilometers, millimeters, and decimeters, and centimeters. These are all units of the distance, but the SI unit of distance is definitely meters, but we can use alternative units depending on the situations and depending on the circumstances, right? So next is displacement. Don't mind putting any questions if you have any question in your mind, right? I'll be very happy to answer all the questions that are asked in the comment sections. So don't hesitate to put your questions. Your questions will definitely tell me about your understanding, and I really want to know how you understand and how you enjoyed it. And also do mention your city, your country, where are you watching from, right? It'll be very, it makes me happy. It makes me happy to know the people from different locations and interact them and to spread knowledge all over the world. Thank you. So let's get back to the idea of displacement. Again, we have 2 points, point A and point B. If you move very straight from point A to point B in a unidirectional and you do not change your direction in any point reaching till point B, so you are covering a shortest length, and that is called displacement, right? How we define distance? Length of a path between 2 points. And how we define displacement? Shortest length between 2 points is called displacement, right? So displacement is a unidirectional. That's why displacement is a vector quantity. It is a vector quantity, and this is a scalar quantity, distance, right? And I have to make some important announcements here. If you want all past papers of all the years, including all the papers and mark schemes and each and everything about past papers, I have gathered them in one folder. You can get that folder. If you want to get that folder, and if you want to have all those past papers from all the past years, you can message me on WhatsApp and can get that one folder that includes all the past papers from all the past years, right? And also, if you think you need this lecture in a PDF format, you can get that also by sending me message on WhatsApp. Just write past papers or write PDF of the lecture. Just mention that topic, and I'll be sending the PDF file of this lecture, and I'll be sending all the past papers from all the past years, right? So till now we have discussed about speed, velocity, distance, and displacement, and our next topic is acceleration, which is important and a little complex, just a little bit, not much, but just a little bit. Okay, acceleration. Acceleration. How we understand acceleration? We understand acceleration with an example. What is acceleration? Again, we have point A and we have point B, and you want to go to point B from point A, let's say you go like that and you start from point A, and here you have a velocity, and of course when you reach out on point B you have a certain velocity, right? And the velocity that you have at point A when you were starting, that is called initial velocity, and we represent as Vi, and you have a velocity at point B which is a final velocity, of course, and that is Vf. And of course it took time to travel from point A to point B, and that time is denoted by t, right? So we define as acceleration, which is represented by A, as the rate of change of velocities, right? So Vf minus Vi divided by t, right? So we have whatever we divide with time t, that comes out as rate, right? So we have final velocity, we have initial velocity, and we're dividing it with time, so it becomes as rate. So rate of change of, right? Change of, this is a change of. Why change of? Because we're finding out the difference of velocities, that is Vf minus Vi over t. So it is rate of change of velocities, right? And now let's discuss about the SI units of acceleration, that is meter per second square, right? How we have, let's get back to the formula, that is called meter per second minus meter per second, right? And yeah, how we calculate meter per second square, we have this formula, which is Vf minus Vi over t. So we have in numerator meter per second, that is the SI unit of velocity, and we have in denominators second, right? When it goes up on the other side, it becomes meter per second into per second, right? So it becomes meter per second square, which is an SI unit of acceleration. Definitely we can use alternative units for acceleration depending on the situations and circumstances. So till we have discussed about speed, velocity, distance, and displacement, and how they are scalar and vectors, and our last term was acceleration, and we discussed about how we can find out acceleration. Of course we can use this formula to find out acceleration, and how to define acceleration, and what are SI units of acceleration, that is of course meter per second, and of course we can use other alternative units to calculate depending on the situations and depending on the circumstances. And the final question is whether acceleration is a scalar or vector. I'm leaving this question for you. If you know the answer and you have the correct idea about acceleration, whether it's scalar or vector, you can answer me in the comment section. I'd be very happy to listen from you. Thank you so much, and do mention your city, where are you watching from, so that I can welcome you in my videos. Thank you so much, and we'll meet in the next lecture. Till then, goodbye.